when we started with right angle trigonometry, the first thing you need is a right triangle. And so in your right triangle, you have 3 sides, 2 legs, and a hypotenuse. All right, the hypotenuse will always be the hypotenuse. The way you label the 2 sides will depend on what angle we're talking about. So let's say we are talking about angle A. Then we need to label this triangle according to angle A. Hypotenuse remains the same, but now we have to label opposite and adjacent. So opposite is like I am standing in the corner A and I'm going to walk across my triangle. That will be my opposite side. So if you're standing here and walk across, you're walking to the opposite side. Y'all would understand that if I said walk to the opposite side of the room, right? And so that's the same thing for the opposite side of the triangle, which means the one that is attached to that angle is going to be the adjacent side, which adjacent means next to, right? All right, so adjacent side. And so now from this, we are going to do our SOHCAHTOA, or our 3 main trig functions. So sine, this is where we use the so part of it. Sine of angle A is going to be the opposite over the hypotenuse. Cosine of angle A is going to be the adjacent over the hypotenuse. And tangent TOA of angle A is going to be the opposite over the adjacent. And so that's just a quick way to remember those 3 trig functions.
It'd be the same for like each angle.
Then we had our 3 reciprocal functions. So if you remember the first 3 and remember which ones are their reciprocals, then you'll be fine. For sine and cosine, it sounds opposite of what it should be. So the reciprocal of sine is cosecant, which means the cosecant is literally just the reciprocal. It's hypotenuse over opposite. The reciprocal of cosine is secant, which means I just flip that and say hypotenuse over adjacent. And the reciprocal of tangent is cotangent, which means I just flip those. So remember, these 6 trig functions are just basically saying I need a ratio between the 2 sides of this triangle based on this angle, all right? So you have SOHCAHTOA, sine, cosine, and tangent, and then you have their reciprocals, cosecant, secant, cotangent. So you may have to use Pythagorean to get a side that you need, or they may give you both of the sides that you need for whichever trig function they ask for. But you need to, 1, decide what angle they're referring to, label your triangle, and then look at the trig function. So I always start with the angle, I label accordingly, and then I do the trig function. So I'm going to do 2 first because it's one of my first 3 major ones, and then we'll do number 1. So let's look at number 2. They are asking me for the sign of theta. Look at which angle they labeled as theta. So they have labeled this angle right here. I am going to label my triangle according to that angle. Hypotenuse never changes. Hypotenuse is always going to be the one that is across from my right triangle. It's going to be my longest side. Then I'm going to look at theta and I'm going to walk across the triangle and see that 16 is my opposite side, which means that the leftover side is my adjacent side. Now I'm going to think about sine. Well, sine is SOHCAHTOA, is S-O-H, opposite over hypotenuse. I don't need to solve for anything here. They've given me everything that I need. So I can just literally list my opposite side over my hypotenuse side. Now, basic algebra, I need to reduce this fraction and I need to simplify the radical if I can. So I'm going to say, 16 and 8, those reduce to 2 and 1. And then the radical, I don't want to leave in my denominator, so I'm going to just multiply the top and the bottom by that radical. And so my final answer here is 2 square root of 5 over 5. So I have hypotenuse, that's always going to stay the same. If I look at this angle and go across the triangle, the 6 is my opposite, the 8 is my adjacent. All right, and they're asking for secant. So if I write out my SOHCAHTOA, then opposite of which one of these, the sine, cosine, or the tangent, is my secant? Right, so I should flip my cosine, which means my secant is going to be hypotenuse over adjacent. All right, I have the adjacent side, but I do not have my hypotenuse side. All right, and so I can use the Pythagorean theorem to figure out that it's going to be a 10, or if you happen to know some Pythagorean triples, 3, 4, and 5, then you can, get into that back the other way if you happen to know your right triangles. But if you don't, so a squared plus b squared equals c squared. Remember, a and b are always your legs. C is always your hypotenuse, right? So I'm going to say 8 squared plus 6 squared equals c squared. So I can say 64 plus 36 equals c squared. 100 equals c squared. C equals 10. So now I know that my hypotenuse equals 10, and now I can put hypotenuse over adjacent. So I can say hypotenuse over adjacent. Do you think I'm going to leave it that way? No, reduce. 5 over 4 is my answer. You are going to use your calculator. It does want you to round it to the nearest degree. And you need to make sure that you are in degrees in your calculator. So you want to check your mode. Make sure your mode says degrees, not radians. Hit mode. All right. Once again, I am going to look at the angle that they have given, that I am trying to solve for, and that's how I'm going to label my triangle. So once again, I'm going to say, all right, my hypotenuse remains the same. If I look at my angle, the other side they gave me was the opposite side. All right, and so I'm going to label this accordingly. Then for these, I am going to specifically say which two sides did they give me? Well, they gave me the opposite side and the hypotenuse. Which trig function deals with the opposite and the hypotenuse? So again, I can go right back to my SOHCAHTOA and I can say, well, obviously my sine is the one that deals with opposite and hypotenuse. So that is the trig function I'm going to use. The sine of this angle that I don't know should equal the opposite side over the hypotenuse side. All right? Which means I need to use the inverse function of sine, not the reciprocal function, the inverse function. So on your calculator, it looks like this. All right? That is, I am trying to find the angle. I am trying to find the angle. And so you need to say, well, 31 divided by 56 using the arc sign. This particular one, and you round it, you should get 34 degrees. Nearest angle, nearest degree. So I do not want a decimal here. Round it to the nearest whole. This next section wants you to find a specific trig function. But they've given you basically one trig function and they want you to find another one. All right? And so what I would recommend you do here is that you probably draw your own right triangle. All right? And then you pick an angle that represents your theta. All right? And then label your sides according to the angle that you have drawn. So we are just basically drawing a triangle and labeling one of the sides. Then look at the particular trig function that they have given you. They have given you cosecant. Secant is the reciprocal of which function? Cosecant is the reciprocal of which function? The sine, which is opposite over hypotenuse, right? Which means they have given you hypotenuse over opposite. Yes? So now you can label it hypotenuse, all right? They gave me the hypotenuse. Opposite, okay, they gave me the opposite, all right? What do they want me to find? They said find tangent, right? What is tangent? Tangent is which of your two sides? Right, opposite over adjacent. I'm missing one of my sides. This looks just like my first page now. Does everybody see how this is just like my first section?
Yeah.
I have a triangle. I have two sides labeled. They want me to find a specific trig function. So all you're doing is you're creating the first section with the information that they gave you. Okay? Now here's the thing. Had they said find sine given cosecant, I wouldn't even need to draw a triangle. All I would have to do is flip it, right? So they could have given me even more information. They could have said, find your sine given your cosecant. Well, I don't need a triangle there. I know those are reciprocals of each other. All I have to do is flip it. But sometimes they're going to give you two that are not reciprocals, and you need to maybe draw your triangle to see what you have and what you need. So if I finish this one out, I would have to use Pythagorean theorem here. So a squared plus b squared equals c squared, right? How do I square a square root? What happens there? Right, so 9 plus b squared equals 13. So b squared is going to equal 4, which means b equals 2. This is right triangle. It's always your positive root, by the way. We will get to positive and negative roots with trig, but for right triangle, it's always positive. So now I have my adjacent side, which is 2, and I can go right back to my tangent. That's what they want. The tangent then is going to be opposite, which I have, over adjacent, which I now have, and that is my answer. All right, so in this case, on this section, now they want you to find a missing side. All right? My first step, I'm going to label my triangle according to the angle that I have. So again, I know I say this over and over, but it's really awful when you take an entire quiz and you label your triangles wrong. All right? So this is one of the most important steps you do on this quiz, is knowing how to label these triangles. My hypotenuse is always the same. If I'm standing in this angle and I go across, that is my opposite. And the angle that is right next to it is my adjacent. So what I'm going to do here is I'm going to say, which two sides did they give me? Well, they gave me my hypotenuse side and my adjacent side. Which of my three major trig functions deal with adjacent and hypotenuse? My cosine deals with my adjacent and hypotenuse. So I am going to use cosine here. The cosine of my angle, which they gave me, was 35 degrees. Should equal my adjacent side over my hypotenuse side. And then I just solve. How do I solve for x? I multiply both sides by 5.4. So my answer is going to be 5.4 times, and you can do it in your calculator, of course, the cosine of 35 degrees. And they do want these rounded to the nearest tenth. So when you put that in, round it to the nearest tenth. All right, so this section says solve the triangle. What it means by solve the triangle is I need every side and I need every angle. I need all of those measurements, all right? And so typically what I will do is I will either label it on the triangle or I will list ABC angles and ABC sides. So when I do this, just so you can see my process, I do, okay, I need the measure of angle A, the measure of angle B, the measure of angle C. I need the side opposite of A, angle. I need the side opposite of B, angle. I need the side opposite of C. All right? And I go ahead and write down what they've given me. Well, clearly C is 90 degrees, right? That's labeled. He's done. B is 62 degrees. That's also labeled. I am missing A. I love these because A is really simple to solve. A is always going to be complementary to B, which means I just subtract from 90. 90 minus 62 is 28. So that's a really easy one to solve for. When they've given me one of the angle measures along with my right angle, they always add up to 180, right? So I can clearly just subtract, right? And so that's simple. Then I'm going to write down any sides that they've given me. They have given me the side opposite of B. So I'm going to go ahead and write that down as well. If it will let me. There we go. And then I know what I need to solve for, all right? So I'm going to solve maybe for this A side here. All right. And I look and see, well, if I have the 62-degree angle, then I have the opposite side here, and I'm solving for the adjacent side. Which trig function deals with opposite and adjacent? My tangent. So the tangent of 62 degrees should equal my opposite over my adjacent. All right, now, really quick, I'm going to show you why this is true, but it will always be true this particular case. Anytime what you're solving for is on the bottom, you can reciprocate both sides, all right, and then multiply. But what happens here is anytime your side length is on the bottom, it's going to end up being, well, the side length will be the 16 divided by the tangent. It will always work out that way. If you don't remember that, look at just the process, all right? We're going to look at the algebra process here that happens, right? I could reciprocate both sides, or I could multiply by A, right? And I have A tangent of 62 equals 16, and then I could divide by the tangent of 62, right? And you can see that A will equal 16 divided by the tangent of 62. So when what you're solving for is on bottom, you're going to end up dividing, not multiplying them. So remember on the other one, we multiplied. We would have said the number times the trig function. But when what you're solving for is on bottom, when that side length is on bottom, it's going to be the number divided by the trig function. Okay? So when your x is on top, you're going to multiply. When your x is on bottom, you're going to divide to get your answer. And that's the algebra reason as to why. So once I do this, if you do this in your calculator, it wants you to round to the nearest tenth. You're going to get that that side length is 8.5. So we have 8.5 here. All right. There's a couple ways you can solve for your hypotenuse. I typically go back and do like my, that way I'm not rounding and then rounding. You could also use Pythagorean theorem, a squared plus b squared equals c squared here. So you could either say, well, I want to use the sine now of this angle. It's just jumped on me. I want to use the sine to do this. The sine of b is going to be my opposite over my hypotenuse. So I could say sine of 62 equals the opposite side, which I don't know, over my hypotenuse. And do the same thing, right? Or you could use your two sides and Pythagorean theorem to solve for your third side. Either way, you should get approximately 18.1 there. All right, so when you do this for me, you can either go in, if you can write neatly, and write your 28 degrees, write your 18.1 here, and write your 8.5 here. Make sure every side and every angle is labeled. Or you can write it out over here, right? Whichever way you feel, you're going to make sure you get every side and every angle. All right, so for number 32, I don't have any angles, all right? So I need to pick an angle and I need to solve for that angle. It really doesn't matter which one. Obviously, I know angle C because it's 90 degrees. Let's say I want to solve for angle A. I'm going to label the triangle accordingly. What is side 16 if I'm looking at angle A? Opposite, adjacent, or hypotenuse? What is 16? It is opposite. What is 10.3 looking at angle A? Adjacent. It's touching that angle. Which trig function deals with opposite and adjacent? Tangent. So the tangent of A should equal my opposite side over my adjacent side. What do I do in my calculator when I need to solve for the angle? I'm going to use my second function, right? So I'm going to use the inverse function, the arctangent, and do 16 divided by 10.3. And they do want this to the nearest tenth. So in your calculators, do the inverse tangent of 16 divided by 10.3. All right, so you should have 57.2 degrees here, all right? Now, to solve for my other angle, my B, I can now just subtract from 90. So B should be 90 minus that 57.2 degrees. So my B angle should be 32.8 degrees. I still have one more thing to solve for, don't I? I have not completely solved this triangle because I'm missing a side. However, I have 2 out of 3 sides of a right triangle. I can go back to a very familiar, hopefully, a squared plus b squared equals c squared. So I can say my a squared plus my b squared should equal my c squared. Now here you will put that into your calculator and take the square root. And I think even rounding to the nearest tenth, you get a 19. Once you have labeled all 3 angles and all 3 sides, you have solved the triangle. You may need to use your inverse trigs, or you may just need to use your regular trig functions to solve, depending on what they gave you. So if you're looking for an angle, you're going to use those arc -1s. If you're looking just for the side, you're just going to use your regular sine, cosine, tangents.